Okay. So I would like to start by asking any of the panelists, if we actually were to achieve some of the dreams that you have for moving to an Internet of Things, what kind of monies are we talking about per city for, let's say, a city of 100,000 people, or scale it up from there if you like? Maybe it doesn't scale linearly. Are we talking about hundreds of millions of dollars per city? Are we talking about tens of thousands? Are we talking about normal things that people buy in their everyday upgrading of things? Anybody want to take a crack at that?
So you mean in terms of saving?
No, money spent to become an internet-enabled IoT city.
May I?
So in this, at least for, I mean, the initial investment that we got, it was for let's say, for such a deployment in terms of equipment, right? So it was less than 1 million euros.
For the whole city of Santander?
For let's say for an area of around 6 square kilometers, which is downtown area. Okay, the city has an area of around 36 square kilometers, right? But based on the fact that we were let's say deploying using mobile devices, more or less with less than 1 million euros.
And
in terms of just equipment, huh? Of
the set of functions that you can envision, would you say that got you in your pilot 1% there, 1/100th of 1%, 50%? I mean, I'm trying to gauge what you get for the $1 million.
So, for example, in energy saving, for the public street lighting, the budget that is allocated to a city as Santander is something like for 10 years, something like, let me think, is around 40 million, yes, around 40 million euros. And we have experienced saving of more than 85%. In the sense that now the manufacturers, the business plan that has been already approved is that the saving coming from the energy is going to be paid in the first, let's say, iteration to the responsibles for the deployment of the new LED technology.
So you're basically saying that this will pay for itself on an ongoing basis,
Yeah.
and maybe we don't need measures of how much it'll cost. We just get savings back. June, do you want to comment?
Yeah, well, actually, the examples I showed, like all the data collected from the cellular phone companies, and that was zero, right? It's automatically generated from the cellular phone owner and then the cellular phone company. So no special investment for the special sensors, but it's collected from the business data. And then for the Netflix things is also the same. It is automatically collected data, and then that's generated the revenue to the companies. So automobile companies, actually all of the companies, not only the Japanese companies, they are collecting all the probe data and then collected the data from your automobile to support to do the services to you, to support your drivers and the owners of the things. So once their data to be utilized, then it's not the additional investment for the kind of traffic management and other things. But that's weather sensing as well. So in addition to those infrastructural investment of the public authority, then the private data can be collected now to be utilized for the thing. So that's a point I wanted to emphasize.
Okay, thank you.
There are several examples. One that's particularly striking. The city of South Bend, Indiana, had a flood management challenge, right? So flooding of the city was an issue. They approved a $100 million bond effort to replace the water management infrastructure throughout the city in order to manage that flooding. But in the meantime, they had been working with faculty from Notre Dame on smart water management strategy. In fact, they implemented that strategy, cost them about $10 million to implement that. So they saved $90 million on their floodwater management project, which they could spend for other things that the city needed. In Chicago, Argonne National Lab and the University of Chicago are working with the city to deploy multimodal sensors of the type that you were talking about, Louise, to a significant part of the downtown area. And that deployment is being done as part of replacing the light fixtures with LED units. And the combined total for the lights and the sensors being deployed, each sensor is about $40. The return on investment, the time to achieve return on investment is estimated at 2.5 years. So very quick turnaround because of the energy savings and the truck rolls that are saved with respect to lighting. So it very much depends on the structure of the project, what costs you're replacing, and what capabilities you're taking advantage of here. And so it's not at all what I would have imagined going into this area.
And my guess is we'll be surprised further because it almost never turns out the way you predict when it's that kind of a change. Do we have time for a question or two from the audience? Okay. It's kind of hard to see if there are questions. I see one over here. We'll take 2 questions and then I'll turn it over to Vind.
Hi, Takashima Tsudoki to University again.
Ken.
Yeah. My question is again about the future or the forecasting near future. You showed lots of sensor network, and based on that, and the probably your system is forecasting what is happening in the very near future, 1 hour later. So how the current technology or how the current intelligence or AI is predicting what is happening and what is the accuracy rate, a good prediction and a bad prediction, what is the ratio or the accuracy of the current technology predicting or forecasting what is happening, like congestions or...
So can we actually get models to forecast things based on the data you're collecting?
Louise, do you want to start with that?
Okay, so may I start perhaps? So as I explained just before, so the traffic management map that you see before, you have seen before, is based on prediction. So the typical traffic management applications report what is happening at time being. However, based on the ability to gather data, key data, we are able, and once I mean we, the traffic engineers working in the cities, are able to make the predictions on how the traffic is going to behave. And this is going to happen not just in traffic, but also I was discussing with water management. So based on the fact that sensors are available and deployed in the pipes, and based on the hydrodynamics models for the water, merging both, we are able to predict which is the demand in water in the next 5 hours and to adjust the pressure in the pipes based on the predictive demand. And this is going to happen in all, let's say, the verticals that you might envisage in the city.
Human eye of engineers?
Isa?
The engineer's brain.
Yeah.
Well, actually, those IoT things we've been talking about is a matter of the scale of the amount of the data is going to be huge, and if that is happening, then accuracy about the data is drastically changed because of the cost of the data versus accuracy of the data ratio. If you introduce exactly what you said about the artificial intelligence and other the software intelligence on the data, if the data scale is very large and inexpensive, then the situation of the accuracy is going to be changed.
The savings in South Bend largely come from predictive modeling and doing smart water management based on that. But moreover, we have never had access to urban environment sensing at this granularity. So the urban science that can be done here is just absolutely fabulous. The kinds of things that we just have not had real data to validate some of our urban models and simulations. As was explained, how you get the population in and out of Tokyo in the case of an earthquake. We just have never had the level of data that we can generate with these systems. So the opportunity, I think, is phenomenal for research progress in this area.
So we'll take one more question from Peter, and Vint, if you want to come up here, we'll just stay here and, while you do your wrap up.
I just have one question. Do you find some of the data on things like noise, pollution, water quality is actually quite sensitive data? Have you found any problems in making that available to the citizen or to each other? Because it obviously has political overtones.
Well, I mentioned in my presentation that the authority, each of the pieces of the data generated from the, what we've been working on as a test, it was claimed by the data authority of each of the segment. The environmental authority was very much complaining that when we are, each of the individuals sensing the water quality of the nearby, rivers, and then the traffic data is basically hated by the police department, and so it's always a conflict for the start point. But then they're going to learn that this accuracy of the data is different from the zone data or infrastructure data is different from the mobile data. Then they. After they understand, then we are now working together.
Yeah, Peter, you're absolutely right. The first question, the number one concern that I hear from mayors who are talking to us about opportunities for smart cities, the number one question is privacy protection. It's not cost, it's not feasibility, it's not even cybersecurity, which you would think would be, another big one. It's privacy. In what ways, are my residents going to feel their privacy is being abused here? And so, privacy by design. The answer to this to residents has got to be a description of how the design, as you were describing, provides for privacy. What have you taken that into account as a first principle for engineering? What are the engineering solutions? What does that mean to me? Is privacy a top priority, and how is that going to be affected? So it's a hard problem, but it's at number one on the list for the mayors.
So I think we need to wrap up. First of all, please join me in thanking this final panel.